Greetings to everyone. Our topic is control charts for variable and attributes as well as their applications. It's made by roll number 4, roll number 33 and roll number 39. Control charts, also known as Shewhart charts, named after Walter A. Shewhart, or process behavior charts, are a statistical process control tool used to determine if a manufacturing or business process is in a state of control. The control charts are the graphical device for statistical process monitoring, otherwise known as SPM. The control chart is one of the 7 basic tools of quality control. The control charts are used for time series data, through they can be used for data that have logical comparability. When to use control charts? When controlling ongoing process by finding and correcting problems as they occur, when predicting the expected range of outcomes from a process, when determining whether a process is stable in statistical control, when analyzing patterns of process variation from special causes, that is non-routine events, or common causes that is built into the process, when determining whether your quality improvement project should aim to prevent specific problems or to make fundamental changes to the process. Main parts of control chart. Center line, the line representing actual process average. Control line, CL, the horizontal line above and below center line to judge whether a process is in control. Upper control limit, UCL, this indicates the upper limit of tolerance. Lower control limit, LCL, this indicates the lower limit of tolerance. Now control limits are for process variation and specification limits are for customer requirements. And right side you can see a graph which showing the quality scales. Types of control charts. Control charts are divided into two, variables and attributes, which is further divided into three. Variables is divided into X chart, R chart, S chart, and attributes into P chart, NP chart, and C chart. Application of control charts. First one is accounting. Payroll function, number of audit exceptions in sample of employee pay records. Tax preparation, proportion of unusual returns due to error. Purchasing, number of purchase discount lost. Next is hospital, lab test accuracy, insurance claim accuracy. Police department, number of traffic citations. Further, there is bank, in which check processing response time. Then it is post office. It is used in sorting accuracy and time of delivery. Next, it is used in hotel. Proportion of rooms satisfactorily cleaned, checkout time, and number of complaints received.
So the next is variable control charts. The first of all, the question is what is variable control charts? Any process performance can be recorded and monitored with respect to a selected variable by using variable charts. Variable charts are those quality characteristics which can be measured. So the next is type of variable charts. There are main three types of variable charts. The first is X bar charts, second one is R charts, third one is S charts. X bar charts is also known as the average chart. R chart is also known as the range chart. The S chart is also known as the standard deviation chart. So the next question is what is X bar chart? X bar chart is used for characteristics that can be measured on a continuous scale such as weight, temperature and thickness, etc. This chart is called X bar chart because the statistics being plotted in the sample mean. The next is what is R chart? The R chart is used to monitor process variability when sample size are smaller to simplify the calculations made by process operators. What is S chart? The S chart is used to monitor process variability when sample size are large or when a computer is available to automatic calculations. Control units. For plotting control charts generally plus or minus 3 sigma selected. Therefore such control charts are known as 3 sigma control chart. So the next is the calculations of chart characteristic. So first of all we have to find center lines and then we will find control limits. The center line for the average or X bar chart is equal to summation 1 to x xi by n. In simple words we can say that add the individual values and divide by the how many values you have. The center line for the range or R bar chart is equal to summation limits 1 to n rm by n minus 1. In simple words, we can say that add the moving ranges and divide by the number of moving ranges you have minus 1. The next is control limits. Here the UCL means upper control limit and LCL is the lower control limit. So the UCL for X bar chart is equal to X bar plus E2 into RM. LCL for X bar chart is equal to X bar minus E2 into RM. UCL for range chart is equal to D4 into R bar M. And the LCL for the range chart is equal to D3 into R bar M. E2, D4 and D3 are the constant. We will see how to take the value of this. Here the one table is mentioned in which constants for various charts are given. These constants are used to find the control limits, and with the help of control limits we can draw the different charts. Now understand how to draw the X bar and the R bar chart from one example. Here we have taken example of SPC for bottle filling. SPC means a statistical process control. SPC is a scientific visual method used to monitor, control and improve process by eliminating spatial cost variation from manufacturing, service and financial process. SPC is a key continuous improvement tool. Here in example we have taken a total 10 samples, and for each samples we have given a total 5 observations, and that observation shows how much seconds taken by one bottle to fill it completely. For every sample we calculate average of 5 observations and also find range R. And how to find X bar and R bar we have already seen in earlier slides of calculation characteristics of variable chart. The next is the calculation for X bar and R chart. The first yellow box is for X bar chart and the second yellow box is for R chart. UCL for the X bar chart is equal to X bar plus A2 into R bar, and the LCL for the X bar chart is equal to X bar minus A2 into R bar. Here we get a X bar is equal to 12. Here we have taken an average of all value given in a column of average, and for R bar also we get from same procedure. UCL for the R chart is equal to D4 into R bar, and the LCL for the R chart is equal to D3 into R bar. A2, D4 and D3 we get from a table of constant for 5 observation. So this is the average or X bar chart for the example we have taken. First of all we draw the center line which is equal to the X bar, and then we will draw the LCL and the UCL. Then we take the value from average column and mark all the points on the graph, and then we will join the all marked points. So we will get the average chart. The all values are between the UCL and the LCL. So all samples are in control limits. So all samples are accepted. If any sample value is above UCL and the below LCL, then those samples are not controlled. So we have to reject those samples. Here we can see that the process is in control and stable. So this is the range or R chart for the example we have taken. Here we will follow the same procedure as we follow in X bar chart. Here also all values are between the UCL and LCL. So the this chart is also stable and under control. So the next is the applications of control variable charts. Control variable chart is used to enable system stability to be evaluated. It can be applied to analyze process improvement results. It can be used for standardization. And it can be used to measure weight, strength, time and other measurements. If any manufacturing plant want to figure out how to improve their process and operations by analyzing results through a statistical method, then they can use these control variable charts.
Now, let us understand what are attribute control charts. But first, we need to understand what are attribute data. The attribute data is data which counts the number of defective items or number of defects per unit. The important concept here is what you are counting. They are used to monitor the stability of the systems where any count or percentage is accumulated. They are the result of an assessment using go-no gauges or pass or fail criteria. The different types of attribute charts include the P charts, the NP charts and the C charts. Now let us understand the different types of attribute control charts. But first, let us understand what are non-conforming units. The non-conforming units are the units that vary from the normal norm or the normal distribution pattern. Now, let us take the first type, that is the P charts. The P charts is used to monitor the proportion of non-conforming units in a sample, where the non-conforming sample proportion is defined as the ratio of the number of non-conforming units to the sample size. Now, let us understand what are NP charts. The NP charts is used to monitor the number of non-conforming units in a sample. Now, let us understand the third type, that is the C charts. The C charts is used to monitor count data type, typically total number of non-conformities per unit. It is also occasionally used to monitor the total number of events occurring in a given unit of time. Now, let us understand the calculations of P charts and the NP charts. First, the center line for the P charts. The P bar represents the total number of non-conforming units by the total number of units inspected. Usually, they are expressed as a decimal, and the N represents the average number of inspected in subgroup. The control limits. The upper control limit for the P charts is equal to the P bar plus 3 times the under root of P bar into 1 minus P bar by N, whereas the lower control limit for the P charts is given by P bar minus 3 times the under root of P bar time into 1 minus P bar divided by N. Now coming to the NP charts. The N raised to P represents the number of non-conforming units. Now let us look at the control limits for the NP charts. The upper control limit for the NP charts is given by N times P bar plus 3 times under root of P bar into 1 minus P bar into N, whereas the lower control limit for the NP charts is given by P bar minus 3 times under root of P bar into 1 minus P bar times N. Here the N represents the constant sample size. Now let us take an example to understand the working of this attribute control charts. A team in accounting group has been working on improving the processing of invoices. The team is trying to reduce the cost of processing invoices by decreasing the fraction of invoices with errors due to incorrect price, incorrect equality, incorrect coding, incorrect address, or incorrect name. The team decided to pull a random sample of 100 invoices per day. If the invoice had one or more errors, it was defective. The data from the last 25 days are given in the table. The following table shows the data from the last 25 days, and the invoices inspected per day are 100. Now we are interested to plot the P charts for the following example. From the calculations, we obtained the value of P bar as 24.8%. The upper control limit for the P chart is obtained as 37.8%, whereas the lower control limit for the P chart is obtained as 11.8%. We get the following graph by plotting the data obtained in the table as the subgroup number against the percentage of defective. From the graph, we can interpret that since the P bar value is 24.8%, which signifies that 24.8% invoices are defective. Also, the data is within the control limits. Now, let us understand the applications of different types of attribute control charts using the example of hospital. Both the P and the NP charts can be used for the number of surgeries that developed a surgical site infection and the number of patients who receive an antibiotic on time. But the NP chart plots the number while the P chart plots the proportion of items. The C charts can be used for the number of patient falls, the number of centerline infection, and the number of needle sticks.